So this begins our lesson on trying to determine the sum of interior angles of different shapes. So far we've learned about parallel lines being cut by a transversal and all the different angle pairs that it creates. Now we're going to look at different shapes. So this of course is a triangle that has 3 sides. The number of triangles that can be created in this shape from one vertex is one triangle. What that means is if I deal with one vertex, vertex is where 2 points meet. So I have 3 vertices technically, 1, 2, and 3. I'm only going to choose one because this says from one vertex. How many triangles can you make from one vertex? Well, from here to that, from here to here, you've only got one triangle that can be formed. So we know that one triangle is always going to equal 180 degrees no matter what. It doesn't matter if it's a right triangle, an acute triangle. It doesn't matter if it's an isosceles, scalene. None of those things matter. What matters is if it's a triangle in some form, the inside measures, if I were to measure all of these angles, will always, no matter what, equal 180 degrees. So let's look at the next shape. The next one is a 4-sided shape. It has 4 sides, so mark that in your notes. And this would be a parallelogram where both sides are parallel. Okay. So let's mark one vertex. It doesn't matter which one you pick. I'm just going to choose this one. And if I draw a line from this vertex to every other vertex, so there, that line's there, that line goes here, but I need to get to this line, so I'm going to cut there and draw a line. So I can draw a line from here to here. I drew a line from here to here, and now I'm drawing a line from there to there. How many triangles did that create? It should have created 2 different triangles. So what that means for you, if you have 2 triangles, then this triangle equals 180 degrees, and this triangle also equals 180 degrees. So how many degrees would the interior angles of a quadrilateral have? Any 4-sided figure. It could be a square, it could be a rectangle, it could be a rhombus, it could be anything that has 4 sides. It's going to have 2 triangles that can be created, so 180 and 180 makes 360 degrees in every single one of these. So I'm just going to write up here, I've got 2 times my 180. That's how I'm getting that, because I created 2 triangles, and every triangle is 180 degrees. Okay. Next, my next shape is a 5-sided figure, and that would be a pentagon. And let's go ahead and choose a vertex. Doesn't matter any one of these vertexes I could choose. I'll pick this one. And I need to be able to connect this red dot to all other vertices. So here, that one's already connected. It's already connected to this one. I need to draw a line to connect to that one, so there that one goes. And I also need to connect this one to this dot, so go ahead and draw up. Now that I have connected, and remember, it's only from one vertex, it's not from every single vertex. So from this vertex, I was able to connect to each of my others, and how many triangles were created? There's 1, there's 2, and 3. So it created 3 triangles. Again, if each triangle is 180 degrees on the interior measures, I have 3 triangles, then you know to take 3 triangles, multiply that by 180 degrees, and that would tell you how many degrees would be in a pentagon. And that should be about 540 degrees. So if I were to measure each one of these angles in here, they would all add up to be 540 degrees. Okay, the next one would be a 6-sided, and that would be a hexagon. Now my drawings are not the best, so just do the best we can. So it kind of looks like a stop sign, but not. It doesn't have 8 sides. It's got 6. So there we go. There's the vertices. Okay. So now if I choose one of these, I'll just choose, let's choose this one. Okay. If I'm trying to draw a line from this vertex to all other vertices, I'm already connected here, I'm already connected there. I need to connect to this one. I need to connect here, and I need to connect here. So, although they may not be the best looking triangles, these all are triangles. So there's 1, 2, 3, 4 triangles were created. You should be noticing a pattern. So a 6-sided figure, you would determine the degrees by taking 4, multiply that by 180 to see how much the interior would end up equaling. So the interior of a 6-sided would be 720 degrees. So if I took a protractor and measured each one of these angles on the inside, it equals 720. And then a 7-sided figure, heptagon. This one's really I'm going to struggle. I'm just going to make it look like the 6, but add another side. So 1, 2, 3, 4, 5. That was bad. 6, and then 7. Ooh, that's real bad. I'm going to wipe that little piece out. Okay. That's terrible, but it's the best I can do. It really is. Let me go over it. So there's 1, 2, 3, 4, 5, 6, 7. A 7-sided figure. Okay. Again, where each one of these meet is called a vertex. So I choose one vertice. So I will pick this one. Doesn't matter which one you pick. And now connect that vertex to all other vertices. So it's already connected here. It's already connected there. So I need to connect here, here, to this vertice, to this one. It's already connected. So I've created 1, 2, 3, 4, 5. So that would be 5 triangles. And then 5 times my 180 degrees would tell me how many degrees are in the interior of a heptagon. And that would be 900 degrees. I don't know why I'm switching colors. It's Christmas colors too. Oh well. 900 degrees. Okay. So, just by using a triangle, you're able to determine any figure with any number of sides as long as you go ahead and take it from one vertice to all of the other ones that it's not currently touching. All right, we will practice more on this thought.